Hi, I'm Stu from Hive Automation and welcome back to the Hive. In this video, we're going to be looking at setting up a DIY surveillance display to display our IPTV cameras on an old computer monitor. We're going to be doing that with a Raspberry Pi 3. So while I roll the intro, why don't you take a moment to subscribe? And if you hit the bell icon, you'll get notified when I release new videos each week. While you're at it, if you like what I do here and you want to support the channel, there's some affiliate links to smart home gadgets that you can buy for your very own smart home and support the channel at the same time without paying any extra, or you can support the channel directly through my Buy Me a Coffee link. Of course, affiliate links and my Buy Me a Coffee link can usually be found on my website, hivemindautomation.com.au. With all of that out of the way, let's get started. So if you've been watching the channel for a while, you'll know that I've got network connected cameras around the house. For the most part, I've got Ubiquiti Unify cameras, but I've also got some TP-Link Tarpo cameras, a Mirabella Genio camera, there's a camera in the cat feeder, and there's even a couple of very cheap, low quality cameras that I picked up from Kmart for $50 about 10 or 11 years ago. One of the things that's bothered me for some time about the camera setup is that I don't have a real-time view of those cameras without then opening up an app on my phone or a web browser. And I realized that I had a spare Raspberry Pi 3 that used to be my Home Assistant server, but I've since upgraded to my Home Assistant Yellow and the Compute Module 4. I also have an old 24-inch 1080p monitor left over from when I upgraded to my 49-inch ultra-wide monitor. So I started looking into how I could use those pieces of hardware to set up a surveillance display. The idea being to set up something like what you might see at a service station or convenience store where it has a multi-camera view, and if there's more cameras than will fit on a single screen, it then cycles through those cameras. I found a couple of different open source projects that suit, and I settled on one called Display Cameras. Now, I saw some other YouTubers do videos on this, and these videos are not particularly new. That said, the process still works almost exactly the same. And unfortunately, it also seems that Display Cameras hasn't had an update to it since about 2018. All of that said, though, I will put a link to the GitHub repository for Display Cameras in the video description. I may take a look at investigating other Raspberry Pi surveillance monitor projects, one of which I saw while looking for this one was called RPiServe. I might take a look at that in the future, but that also has some of the same limitations in that it needs to run on an older version of the Raspberry Pi OS. At least for now, Display Cameras does exactly what I need, and spoiler alert, I've been running this for a couple of months now and it's been fantastic, but we'll get to that a bit later on. So we're going to need a couple of things to make this work. Before we go too deep down the rabbit hole, it's important to understand that any cameras that we're wanting to show on the surveillance display need to be able to send real-time streaming protocol or RTSP video. In my particular case, my Ubiquiti Unified Dream Machine Pro has the ability to restream multiple RTSPS streams over the network from any of the cameras connected to it. I also found out that the TP-Link Tarpo C210 cameras that I've reviewed in previous videos also have RTSP streaming available. You may be able to get a bit creative with some intermediary services if you have a camera that doesn't have RTSP built in, but it's going to be a lot easier if RTSP is native. All of that stuff is not the topic of today's video. We're just going to be looking at cameras that do RTSP streaming without having to add anything else into the stack. We're going to try and keep this as basic as possible just to get display cameras up and running and create our surveillance display. Before we get started, we're also going to have a much better time if we take note of the RTSP stream addresses that you want to make use of. I'm not going to go through finding the RTSP addresses in this video either. That, again, that's not the purpose of this video. What you can do once you have an RTSP address is you can open up VLC Media Player on your computer, and if you go to File and then Open Network, or the Command N on a Mac, most likely Control N on a Windows device, what you can then do is grab that RTSP address, which I will grab from my notes here, copy an RTSP address and then paste it into this URL. We can then click on Open, and if everything has worked, we should get an RTSP stream there. Now, in some cases, you'll also get audio, but not in all cases. Not all cameras will have audio carrying over the RTSP stream, and some might not even have a microphone. But if I unmute this in OBS, just turn that off. So provided when we do that in VLC, we get the camera stream, then everything is fine. That address is the correct one, and we're going to use that one when we come back later and put this into our configuration for display cameras. Hardware wise, we're going to need a Raspberry Pi. Now, it does seem from the documentation it may need to be a Pi 3, but I'm not 100% certain of that at this point. In my case, it's perfect because I do have a Pi 3 here that would otherwise be sitting there gathering dust. Display cameras also seems to have a bit of a hard requirement for a specific version of Raspbian. The Raspberry Pi operating system as well seems to have a requirement for Raspbian Buster, which is a little bit older now. And the GitHub repo recommends the light install of Raspbian as well. So there's less stuff getting loaded during the boot to keep some system resources free. I will put a link in the video description for where you can download Raspbian Buster Lite from the Raspberry Pi Foundation as well, so that you have a source and it's from the Raspberry Pi Foundation, not from any kind of mirror sites or anything. We'll obviously need a way to power the Pi, and we're going to need some kind of display and a cable to plug the Raspberry Pi into the display. The Raspberry Pi 3 has a full-size HDMI port on there, so you should be good to go if your display has an HDMI input. Just any old HDMI cable will do. For the setup, we're also going to benefit from having a keyboard handy so that we can type some commands into the Raspberry Pi. That said, we could also enable SSH on the Pi so that we can then get a remote shell and set it up that way. And honestly, that's my personally preferred way to do it. But for the purposes of this tutorial, I'm going to use a keyboard and the display connected directly to the Pi. In my setup, I've also got a 3D printed case for the Raspberry Pi that then mounts onto the VESA mount of the back of the monitor to then keep the setup relatively tidy. I may at some point look into investing in a much shorter HDMI cable to tidy the cabling up even more. But at this point, it's perfectly fine as is. I'm not too worried about it. For the most part, I don't really see the cabling at all. So first things first, we're going to need to flash the Raspbian Buster Lite image onto a micro SD card to boot the Raspberry Pi up. I have a micro SD card and an adapter here, and I'm going to plug that into my Mac here. And we've got our Raspberry Pi imager open already. And I'm just going to choose my device here, and I'm going to choose a Raspberry Pi 3 from that list. From the OS, I'm going to scroll all the way down and choose Use Custom. And in our downloads folder here, I've got my 2020-02-13 Raspbian Buster Lite image there, which I will open. And then I just need to choose storage, and I will choose my Apple SDXC reader media. I'm going to click on next here, and then it's asking, would you like to apply OS customization settings? Now, I've previously cleared these settings, so I'm going to click on edit settings, and I'm going to set my host name to display cameras. For the purposes of demonstration, I'm not going to change the username and password, but it is probably ideal to make sure that you do change that. I'm going to configure my wireless network settings here as well. I'm going to select Hive Mind IoT and put in the password for that. And HiveMind IoT is my 2.4 gigahertz only Wi-Fi network. For the Raspberry Pi, it shouldn't matter. I will set my locale settings to Australia, Melbourne, and the keyboard layout to US. On services, I'm going to enable SSH, and for now I'll leave use password authentication on, but it would probably be better at some point in future to use the public key authentication only and set an authorized key so that we're only using SSH keys rather than sending passwords over SSH. I'm just going to hit save on that. We will apply those customizations. It's going to erase all the data on the card. I'm going to click yes, and it's going to ask me for my password for the computer, which I will type in here, and it's writing the card. This will take a couple of minutes. It'll then verify the card as well. And once that's done, we can head over to the Raspberry Pi and boot it up. Okay, and it's telling us that the Raspberry Buster Lite image has been written to the card, and we can remove the card from the reader. So I'll tap continue, and then we can take the card out. So now that the SD card is flashed and verified, we can go put it into our Raspberry Pi and boot it up. And powering it up. And we should hit startup sequence. Okay, so my Raspberry Pi is started up. I'm going to log in with Pi and then Raspberry, which is the username and password that I set. Those are normally the default username and passwords for a Raspberry Pi. It's recommended that you change them. It says there SSH is enabled and the default password for the Pi user has not been changed. It's a security risk, blah, blah, blah. Normally, I would not use those default usernames and passwords, and I would also normally enable SSH keys. So with the Pi up and running, we can start getting display cameras installed. Now, normally I would go through ensuring that a whole bunch of prerequisites are met, but it does seem that the install script for display cameras handles most of that for me. And the install script will tell me as well if there's something missing that I need to either install or configure. Before we do that though, I am going to do a couple of things just to make sure that our OS is up to date. Because this is an older version of Raspbian Buster, I want to make sure that we don't have any old software on here. So I'm going to run sudo apt-get and then --allow -release info -change and then update. And I'm going to try that again because I mistyped it. That's better. And that's just going to run an apt-get update and allow for the suite value to have changed from what it was as stable, and now it's changed to old stable. And I had a couple of issues before, and I've done some research and found that this is the way that we can then bypass that particular problem, and it should also then allow us to just run apt-get normally now. So I can then run a sudo apt-get update and then sudo apt-get upgrade -y, and this should work just fine now because we've done that allow release info change. And you can see there's quite a bit of stuff that's getting patched there, including some cryptographic libraries, OpenSSH, and a couple of other things there. So there would have been some vulnerabilities on this device as it was with those older versions of some of those things. Okay, so that took a while. That took about 30 minutes or so to install all of those updates. So I'm kind of glad that I did it, but also kind of annoyed at the same time. What I am going to do, and purely because I saw a couple of prompts that suggested that this needed to be done, is I'm going to run a sudo reboot before we kick off, and then we should be able to go. Okay, so now that we have rebooted, I can type in Pi and then Raspberry, and we are logged in. Everything should now be up to date, and we should be good to go. I'm just going to see if there's anything in this folder, which there isn't. This is my home folder, and I'm now going to run wget, and then I'm going to type in the address of the tar file for the display cameras repository. This way I don't need to download it using a browser and then transfer it to the Raspberry Pi. So https://github.com/anonym display cameras/archive/refs/tags/0.8.3.3.tar.gz. So we should be able to run that, and we got not found. So I've stuffed something up there. There we go. There we go. Third time's the charm, and we downloaded 19.7K. So if I just lslah that, we should see now that we have 0.8.3.3 tar. I'll just ls there just to make that a bit tidier. And so we've got 0833 tar gzip. So what I need to do now is untar that, which I'm going to type in tar xzvf and 0.8.3.3 tar gzip. And we should then have lslah, and we should now have display cameras 0833 as a folder there. And I'm going to cd into display camera 0833 there and see what's in here. So we can see the install.sh file in there. I'm going to need to run chmod +x install.sh, and then what we should have is it is now executable. Now we should be able to run this install script with root privileges, which is required. I'm going to run sudo /install.sh, and it's going to try to install anything that it needs. And hopefully it'll also warn me if there's a problem. Being prompted, enter a custom GPU split if required, GPU memory in megabytes, or hit enter to use a recommended split. I'm going to just hit enter and let that do its thing. It's chosen 192 megabytes of GPU memory allocation there. We can then also view the README. This is the same as what we would have seen on the GitHub site. I can type yes there, and it says use the spacebar or page down to page down, page up to page up, and Q to quit. So we'll enter, and we can just kind of scroll through there. I'm going to hit Q just to quit out of that. So now that means that display cameras is actually installed, and now we need to go about setting it up and configuring it with both some camera feeds and a layout. So we're going to need to cd to/etc/display cameras. And what that should do, if I lslah in here, we've got our displaycameras.conf and our layout.conf.default. Both these files define the behavior of display cameras, and then our layout.conf default is obviously the default layout that's going to load, but you can have additional layout files for different screen resolutions. What I'm going to do, I'm going to run sudo nano display cameras .conf, and we need the sudo there because the ownership of the file won't allow us to write to it if we don't put sudo there. So I'm going to open that up, and we're just going to scroll through here, and I'm going to take a look at some of the settings. So our global options, do we need screen blanking before displaying the cameras? The default is false. I'm going to remove the comment at the start of that line and change it to true. And the reason I want that is so that it blacks out the screen before it starts to load the camera streams. Otherwise, when we start the Raspberry Pi up after boot, we've got all of the Raspberry Pi boot sequence stuff happening. You end up seeing the Raspberry Pi boot sequence stuff before those cameras load up. I just like to have it blank the full screen first. It's not super important, but it is something that can make it a little bit nicer. Now we've got the amount of sleep time that we allow per camera when starting, restarting, or repairing, and it suggests recommending no less than 3 seconds of start sleep and no less than 1 second of feed sleep. And you can increase this if you're running higher resolution feeds, a large number of cameras, or you're running over a slow network link. I like to bump this up to about 10 seconds, and that's just so that because we're on Wi-Fi, it allows us a little bit more time. Then we've got retry as how many seconds of sleep that the script waits after the start or feed sleep for the player to first then report playback. So we'll leave that at 5 seconds. We can come back and change this later if we need to. We've got enable display detection, which is disabled by default. What this allows us to do is if we're setting up multiple layout configuration files, so like I mentioned, if we had layout.conf 1280 by 1024, it would then detect the display size and then go and load that particular layout. We've got when rotating camera feeds across the display, how many seconds does each rotation last? The default is 5, and you can change that. So you can change that, say, for example, they have a rotate delay of 8 in there. I'm going to leave that at 5 as the default. Again, if we wanted to, we can come and change that later. Because we've changed something in this file, I'm going to hit Control O to write the file out, and then I'll hit return, and then I'll hit Control X to exit out. And I'm just going to clear the screen and then LSLAH again. And now we want to sudo nano our layout.conf.default. And this is where some of the magic kind of happens. This is where we define window names, window positions, our camera names, our camera feeds, and lastly, whether or not we're going to rotate cameras through the window matrix. First things first, I'm going to uncomment the rotate true there because I do want to rotate our cameras through the window matrix. We have our windows, so we've got upper left, upper right, lower right, off screen 2, and off screen 3. So we can define with this default setup up to 7 camera feeds. If you wanted to define more, you are going to need to then add in another camera feed. So for example, we could put in off underscore screen 4, and then we would also need to define a window position for that. Now, as you'll see in the comments at the top, this example defines 7 half HD windows, 3 of which are off screen to the right, through which the service rotates 6 camera feeds. It actually only uses 6 windows on a full HD monitor. If that suits your needs, we can modify only the camera names to taste and the feed URLs to what our cameras or NVR is providing. Now, this should, for the most part, be perfectly fine, but I've added the off-screen 4 in here, and we would actually then also need to define that window position for off-screen. So we've got off-screen 1, off-screen 2, and off-screen 3 there. So I'll go here and I'll go 9. So I'll go 960 by 540 window. Just we've had 1920 and then 2880. So I'm going to go 2880 and then 540. We're going from 2880 to 3839 and 540. We're going to go to 1079. So what you might note here is that 0 to 959 and 0 to 539, 960 by 540, which conveniently is exactly half of 1920 by 1080. So this row here that starts at 00, that starts at the first pixel in the very top left-hand corner of the screen to the 960th pixel down and the 540th pixel across, basically meaning that it's going to take up the top left-hand quarter. This one is then going to be the top right-hand quarter, bottom left-hand quarter, bottom right-hand quarter, and then these four here, including the one that I've just defined, are now off screen. Down here, we can now define our camera names, and we just add these as an array of string. Camera names can't have a space in them. They can only have underscores. I'm going to start with tarpo_cam_1, tarpo_cam_2, we could keep going, but we would probably need to define those windows just up here. So with those 8 names defined here, we now, in our camera feed section, need to enter our camera stream URLs. So we're going to be putting our RTSP addresses in here, and it is worth noting that there's little to no point in sending full quality streams to display cameras because it's not going to be doing any recording, and sending full quality streams is going to introduce some latency into the stream. So you're going to be better off making use of the lowest quality streams that you can bear. And that's going to reduce the load on your Raspberry Pi, especially if you're connecting the Raspberry Pi to the network wirelessly. Something else to mention here is that streams from Tarpo cameras are authenticated. So unfortunately, we're also going to need to enter the username and password details in clear text into the URL for these streams. So I will fill out the details of one of these streams, and then I might kind of speed through the rest there. And then we'll get the server started up, and fingers crossed everything's going to work. So I'll start off with our first camera here, and I'm going to start with RTSP://. Now this first one, which was TarpoCam1, is going to be, so I'll just put TarpoCam1 here. This first one in here, TarpoCam1, is going to be a TarpoCam, as the name suggests, so it needs the authentication details. So I've set up a local account on this camera called Home Assistant, and I just set the password for the purposes of demonstration to password, and we're going to then put an @ So we've got Home Assistant and then a full colon and then @, and then we can put in the IP address, which is in this case 192.168.1.51, and then /stream2. Stream2 there is simply about making sure that we're using the lower quality stream from the Tarpo camera because we don't want to overload with the higher quality stream. I'm going to put Tarpo Cam 2 in there, and we're going again RTSP://home assistant password and then @ 192.168.1.122/stream2 for this one. Door camera, and this one's coming from my Ubiquiti Dream Machine Pro, which introduces a bit of an interesting challenge. So we have RTSP://192.168.1.1, which is the IP address of my UDM Pro, and then we're going to go :7447 for the port, and this is because we're going over RTSP-S, which is an SSL encrypted channel there. So then for the camera address, I need to grab a encrypted string here, which is a little bit challenging to copy over without using copy paste. So I'll just type this in. So that base 64 string, and then we've got a question mark, and I've got enable SRTP in that string there. Now what I'm going to do here is Control O and then return to write that file out. And what I'll do is SSH in so that I can copy and paste the rest of the camera streams here. I will do that very quickly and I'll reopen the file to show you when I'm done. Okay, so I've edited the file. I'm just going to sudo nano layout.conf default again, and we'll scroll down. So I've added a couple of extra cameras in as well. I added my office camera and my lounge camera in as well. So what I'm going to do is I'm just going to add those in here. So I've got, so now we've got 10 cameras. So I think I actually am going to need to define at least 2 more windows. I'm going to try without doing that though. So now that I've added the names correctly, I'm just going to exit out and I'm going to clear the screen. So now that I've set up everything, I mean, theoretically we should be good to go. I just don't know whether or not we're going to break something because I haven't defined the screens for those additional cameras. I'm going to try and start up display cameras now, and there's a couple of different ways that we can do this. We could just reboot the Raspberry Pi, and because it was installed as a systemd service, it should start up as soon as it finds that it's got an IP address, etc., and start displaying the camera feeds. We can also run sudo systemctl start display cameras, and that should also start up the service as well. What I want to do, and just because we're going to do some troubleshooting here, is I'm going to type in /usr/bin/display cameras, and I'll run that, and it says it must be run as root. So I'll type in sudo bang bang, and it's going to tell me that I've got the usage wrong. So I need to run it start, stop, restart, repair, status, positions, rotate, or rotate reverse. So sudo user bin display cameras, and I'll type in start here as well. And it's blanked out the screen, which is a good start. And we have a camera loaded. That camera is the TarpoCam 1 that's pointed at the back of the screen, and you can see the 3D printed enclosure with the Raspberry Pi there. We've now got the second camera there, which is the Tarpo 2 camera, which is pointed directly at me. And we've got the front window camera, which is another Tarpo C210 camera that I have around that is pointing out my front window. We've got our front door camera. That's one of the Ubiquiti Unify cameras. And it's loading cameras now off screen. So what we should start to see is it should start to rotate through these cameras. But you should also notice that the timestamp in the top left-hand corner of each of those cameras is in sync. I'm noticing that the streams are roughly a second behind, maybe half a second to a second. So as I'm talking, my lips are out of sync with what I'm saying. So that's something to bear in mind, that there is a little bit of a delay there, but it's not too bad. And especially considering we're on Wi-Fi, that's actually pretty reasonable. Now, something I'm not seeing here is it then cycling through some additional cameras. So I am wondering a little bit if maybe if we haven't defined those additional displays, that this is causing the problem here. Let me just check. Okay, so I've just run a status call on the service, and it's telling me that the other cameras are not playing. I'm going to take a guess that that's because I've broken something there. So I'm going to hit Control C a couple of times here. So yeah, we've got waiting for Alfresco cam, Breezeway cam failed playback. So hard to say what's going on there. So I'm SSH'd into my display camera's Raspberry Pi here. I'm going to install Vim. So I'm going to run a sudo vim /layout, and I'm just using Vim purely because I'm personally a little bit more comfortable with it than Nano. But you can probably just use Nano if you like. So I'm going to again go in here, and we're also going to need our list of windows here. Screen 5 and off screen 6. Okay, so we've got those. I can write that out. What I'm also going to do is the same. So sudo vim displaycameras.conf, and I'm going to update some of the feeds here. I'm going to set my retry here I'm going to set that to 10 seconds. I'm going to set my start sleep. I'm going to set that to about 15 seconds. So I'm going to write that out, and then we should be good to go. What I'm going to do is I'll run sudo user bin display cameras and start, and I'll run that from here, but I'll swap over to other screen capture so that we've got that there, and hopefully when I press return on my SSH terminal, we should get that kick off, which it has started, and I'm also able to see my output, my console output on my laptop screen here. So you can see that we've got our console output. I'll pop back over to the actual output from the Raspberry Pi there though, and it's starting up TarpoCam 2 now, starting up the front window camera now, should be the front door camera now. There we go. So it's trying to start the driveway camera now, and hopefully it will then rotate through on the display here as well to show us that. The driveway camera started, starting up the breezeway camera now. Okay, so had some trouble with the breezeway camera. It's starting up the alfresco camera now, and it's having some trouble with that as well. It's trying to start up the garage camera, and I'd be willing to bet that it's probably going to have trouble here as well. And it is. Trying the office camera, trouble with that. Lounge room camera, and it's having trouble with that one as well. So something kind of funky going on with my configuration here. I might need to take a closer look. So it says it's running a repair on the failed feeds. So it's trying to start the breezeway camera now. We head back over to the capture there. You'll note that it's not cycling through the feeds, even the ones that it started. I'm not sure why it wouldn't do that. I'm actually going to cancel this, so the capture is now blanked out. What I'm going to do is I'm going to sudo reboot from my SSH session. I'm going to restart the Raspberry Pi here, and we'll see if it comes up when it reboots. And it's automatically started up, which is a good thing. Okay, so this time it's having trouble loading the second TarpoCam, so I'm not sure what that's about. So because this is now running as a service after rebooting, I'll head back over here. I'm going to sudo systemctl stop display cameras, and I'll head back over to the capture, and if I run that command now, it's going to stop the service, and you'll see that we're sitting at the login window now. So we didn't even need to log in for display cameras to start up. So what I've done is I've modified our layout configuration back to the default. So it's just got the 7 tiles, but it's still got the 10 cameras defined. So I'm going to see if that helps me out at all. So as before, user bin display cameras start. And we'll run that, and it's going to try and kick off. Okay, so we've got our main 4. Driveway is loading now. And this is where we started to have trouble with, it's trying to load the breezeway cam. And it started this time, starting the garage cam. It could also be that I just had to restart the system. Now it's had okay, so it's glitching out a bit. Started the lounge cam. Okay, so it's kicking off the camera rotation. So the lounge room camera, okay, so it's actually having trouble because I don't have all of the tiles defined. Yeah, I'm going to need to have another look at that layout. So this is going to put us at 3840, 0, and we're going from 3840, 0 to We're going to go 4800, 3840 plus 960. Yeah, 4800 and then 540. And what I'm going to do now, I've updated that. I'm going to go sudo reboot, and we'll go over to my capture card and I'll sudo reboot that, and let's see how that looks now. So the Pi's rebooted and everything's starting up now. So we've got our first camera feed up, our second camera feed, third camera feeds up, fourth camera feeds up. And now we kind of don't actually know what's happening until it starts cycling everything. So fingers crossed everything works this time and it just starts cycling through. Okay, so apparently all of the cameras are playing. So any second now, it should start cycling through. There we go. So it is cycling through those cameras, and it should be doing that about every 5 seconds. It's going to cycle to the next set of tiles. And we've got our 10 tiles defined and it's cycling through and everything's looking nice and clean. We're not getting any kind of glitching this time around. The office camera's currently got a bunch of stuff piled up near it, so it's not very clear, but that's perfectly fine. As you can see though, everything is working now. So it took us a little bit of time to get there, but you can see now that everything's running. Because Display Cameras is set up to be a system daemon, it starts up as soon as the Raspberry Pi has finished booting and it finds the network, etc. So it's actually really clever about waiting for the network before it starts. So that's been setting up a Raspberry Pi surveillance display. It took us a while, but we got there in the end. Now, I've been running a setup very similar to this live for a few months now, and it's been pretty awesome. I have it set up in my office, up in my peripheral vision, so that I can see when deliveries are arriving when I'm working from home, see when guests are arriving if we're expecting company, and I even get a reasonable idea of things like weather conditions, and I can keep an eye on any kind of issues that might be going on outside. The best part is that I don't end up needing to keep a browser window open on my laptop or an app open on my phone to see what's going on. And it's also all in one place instead of having to have the Protect app for my Unify cameras or the Tapo app for the Tapo cameras or so on and so forth. Because having to open the app, for example, by the time the posties rung the doorbell, it's already too late for me to open the app. By the time it loads, they'll have left the "sorry we missed you" card and driven away. So if you're looking for a way to display your surveillance camera RTSP streams using a Raspberry Pi 3, this is a pretty great way to do it. And it's not just for home use. You could reasonably set up something like this in a business context as well. I will be taking a look at a bunch more video surveillance related projects over the next little while, including using some machine learning to identify objects that are appearing on our cameras and then pass that information on to Home Assistant. As always, let me know what you thought of this video in the comments section below. If you like this kind of DIY problem solving content, please let me know of other problems that you're looking to solve, and it might end up becoming a video. That's all we have for this video, and I do hope that it's helped you in your home automation and home surveillance journey. Be sure to drop a comment below with home automation ideas that you'd like to see me cover in a future video, and don't forget to follow Hive Mind Automation on Instagram and Facebook. If you like this video, hit that thumbs up button down below to give it a like, and if you're not already subscribed, now's a great time to change that. If you hit the subscribe button followed by the bell, you'll get a notification when I release new videos, which is normally each week. Lastly, if you like what I do here and you want to help to support the channel, there's a Buy Me a Coffee link in the video description. Any contribution you make through Buy Me a Coffee does get put towards making more and hopefully better content for you to enjoy. Don't forget to check out my website, hivemindautomation.com.au. Thanks so much for watching. I'm Stu from Hive Mind Automation, and I'm looking forward to seeing you next time. Bye for now.